Hello everyone, let's understand QR decomposition using the Gram-Schmitt process step by step in a simple and clear way. So, firstly, what is QR decomposition? QR decomposition splits a matrix A into the product of two matrices that is briefly given by A equal to Q into R, where Q is an orthogonal matrix, where its columns are orthonormal vectors, and R is an upper triangular matrix. And the use of Gram-Schmitt method is to convert a set of linearly independent vectors into an orthonormal set. Step-by-step processes include letting a vector A, and then each AI is a column vector. We want to find orthonormal vectors so that scale us to find A equal to QR, that is equal to, that actually ranges from Q1 to Qn, and a product of Rij. The step 2 is to start with A1. Let Q1 equal to A1 by mod of A1. This gives the first orthonormal vector. And the step 2 is to remove projection of A2 on Q1. That is achieved by giving R12 equal to Q transpose 1 into A2. And U2 is given by A2 minus R12 Q1. And finally, we get Q2 equal to U2 by mod of U1. Now Q2 is orthogonal to Q1. And the step 3 for general AK. Repeat this for all columns of A from j equal to 1 to k minus 1. Rjk will be equal to Qj transpose into AK. Uk is equal to AK minus summation of j from 1 to k minus 1 Rjk Qj. And finally, we can get the value of Qk such as Uk by mod of Uk. Finally, the matrix Q will be equal to square bracket Q1, Q2 up to Qn. The matrix R contains Rij, which is equal to Qi transpose into Ai, and it's actually an upper triangular matrix. Now let's explain the code by step. Firstly, we are importing NumPy as NP, which is a powerful library for numerical computing in Python. And next, we are declaring a function def QR decomposition A. We are also reshaping it. Actually, this function takes matrix A as input, and n represents the number of rows and m number of columns of matrix A. And then we create two empty matrices Q and U, and U is for storing intermediate vectors, which is not normalized, and Q is the final orthonormal vectors. And then we are actually copying the first column of A into U, normalize it to make the first column of Q, that is Q1 equal to A1 by mod of A1, which is actually represented by U bracket is 2 comma 0 equal to A bracket is 2 comma 0, and Q bracket is 2 comma 0 and U is 2 comma 0. These are the standard syntaxes of Python language. And then we are actually looping over the remaining columns of A. We are starting with the column vector from A, removing the projection of this vector on all previous Q vectors. And here, A column is 2 comma I, a Q column is 2 comma J is the dot product, multiply it by Q and subtract. And finally, we normalize the result to get a new Q column. After this, we are constructing the R matrix, loop over upper triangle, that is, I is less than or equal to J. Formula goes like Rij equal to Qi transpose Aj. And after these processes, we actually succeeded in proving Gram-Schmitt method. So we are finally printing the matrix Q and the matrix R. So here the input actually is gotten by the user. Like the user enters a matrix and this is converted to a NumPy array and passed to the function. The output, you'll get a Q matrix with orthonormal vectors as columns and an R upper triangular matrix. They completely satisfy the condition A equal to Q dot R. Thank you.